given my experience with that level of project, I think it's great for the government to send in and do an Apollo-like investment to push the boundaries of science. So the simplest way to think of the bitter lesson is if you are designing an algorithm for AI, you can be very, very clever and make it super, super efficient, or you could just make it such that it scales with the amount of compute. And if you just make it so it only scales the amount of compute, you throw more compute at it, and then over time, you'll get to the answers that you want. And so the bitter lesson is always prefer to just do the dumb approach that scales with the compute rather than the clever approach where you may not be able to add more compute to get better results. GDPR was probably the best thing that could have ever happened to Meta.
Hi, welcome. This is the From the New World podcast. Today I'm speaking with Martin Casado, general partner at Andreessen Horowitz, and the CTO and co-founder of Nicira. We discuss scaling challenges in AI, whether we need more experimentation with different algorithms, the bitter lesson, information theory bounds for data, and the challenges with synthetic data, as well as the role of little tech in politics. I've gotten to know Martin more and more, both in terms of politics, in terms of AI laws, as well as in terms of technical discussions, and as we discuss in this episode, the real meat of thinking about investing and building AI technologies. If you want to help the show, the best way to help us out is to let a friend know, in person or online. Not only are you helping us, but you're helping your friend find something interesting and informative. Without further ado, here's Martin Casado. First question. Yeah. Are we headed towards an AI monopoly?
An AI monopoly? I don't think so, actually. You know what's interesting is when this stuff first happened, we were like, oh, this looks like software. And now if you actually look at the capital expenditures, it looks a lot more like hardware, like ASIC design, where you do have dominant players, but you do have a long tail of specialized players, and it's looking a lot more like that. We've seen this movie before, and so I don't think there's a natural monopoly here.
Interesting. But if you look at the AI hardware, actually, it's almost flipped, right? There's actually much more market concentration in NVIDIA.
Yeah, for sure. So NVIDIA was in a great position. I mean, you can make the same argument for Intel when it came to x86, by the way, right? And so this isn't unique on the hardware ecosystem for having a dominant player. You can attribute to many things, right? You can attribute to the fact that NVIDIA has the interconnect. None of the other hardware players has the interconnect. They have the CUDA software layer. None of the other players have that software layer. So you can actually attribute it to a piece of the technology stack rather than some systemic aspect of the industry that is going to prefer monopoly, as opposed to, say, telcos, where there's a network effect. The marginal cost to add a user goes to zero, and so you get a natural monopoly. Same with kind of railways, etc. I don't see that within the AI ecosystem.
Right. So there's two levels of thinking about concentration or thinking about monopolies. One is natural monopoly. We've seen this pop up more and more with social media. Peter Thiel's book, 0 to 1, was famous on this. And then the other way of thinking about it is these kind of path-dependent monopolies that can eventually, come down. Have we been thinking about the natural monopolies too much when it comes to AI?
Yes, I think so. And that is because we just came out of the social networking era. Remember, social networking has a network effect. So therefore, if you add somebody, the product gets better because the number of pairs increases by the square of the users, right? So you have this kind of super linear effect, and these are natural monopolies. We also saw this with the telcos very famously. There's zero indication that AI has the same property. In fact, it almost looks like the opposite, which is because these models can be distilled so effectively to help third-party models with post-training, it's almost like if you're a leader, then you give an advantage to the people behind you, as opposed to a natural monopoly where if you're a leader, then you can distance yourself from the challengers. And so it's almost like we have a vicious cycle, not a virtuous cycle, or a perverse economy of scale, not a positive economy of scale.
Right. And is that why we are all stuck at kind of GPT-4 level models?
So
there's like 6 of them now?
Well, that's a good question. So it could be that, or it could be that we've actually exhausted the token space, and therefore everybody kind of got all the available tokens with, let's say, within a factor of 2, and we've exhausted all of those. The reason that we got all to GPT-4 so quickly is probably a combination of the two. The first one is the step to GPT-5 requires another breakthrough, or using different techniques than just slurping up all the tokens. And then 2, the reason that everybody cut up so quickly is because distillation is so effective. And again, by distillation, I mean you use the larger model to create training data for the smaller models.
So there's this famous phrase in machine learning called the bitter lesson.
Yes.
Do you want to explain the bitter lesson to the audience?
So the simplest way to think of the bitter lesson is if you are designing an algorithm for AI, you can be very, very clever and make it super, super efficient, or you could just make it such that it scales with the amount of compute. And if you just make it so it only scales the amount of compute, you throw more compute at it, and then over time, you'll get to the answers that you want. And so the bitter lesson is always prefer to just do the dumb approach that scales with the compute rather than the clever approach where you may not be able to add more compute to get better gains.
Right, and you need the compute and the data to scale, right?
Yes, the compute and the data to scale.
Is it time to take a step back from the bitter lesson?
Well, I mean, yeah, I don't think anybody knows the answer to that question, because at some point in time you run out of data, and so you can't really apply it. I mean, the way that I think about AI is these are universal function approximators, right? They can approximate any function, and we know how to do this in a way that scales by compute, but we don't know how to do this in a way that scales by data, right? And so the problem has become, how do you get data that from an information theoretic standpoint has new value, right? That's what the problem reduces to. To me, this is an orthogonal dimension to the bitter lesson. Does that make sense? Like,
right.
Like if you still have, like, even if you're applying to the bitter lesson of making sure that it scales with compute, you still have to solve this other problem. And so the bitter lesson is a guideline to algorithm development on compute. It doesn't tell you how to deal with data. And I think this is what the constraint is now.
Yeah, that's interesting, because there's 2 ways to think about the synthetic data approaches, right? One is this purely statistical interpolation that goes on with, some of the routine generation of data, some of these virtual environments, for example. And the other is a kind of in-algorithm algorithm. I think that's closer to the kind of constitutional AI approach that Anthropic has, where they're using the model to give itself feedback, and it's this kind of algorithm within an algorithm. How do you evaluate the 2 in comparison?
Well, I want to step back. I appreciate the question, but you said synthetic data, not me.
Okay.
And so first, you're presupposing that the answer out of this morass is synthetic data. So let's have that discussion first, and let's get to synthetic data. Does that make sense? Okay. So there's a very interesting observation you can make, where the most economically successful models are trained on human-created data. The image models based on art, even photographs, you select what's going on via like what you decide to take a picture of, like how you focus, what zoom level, etc. So it could be the case that the current economic state of these models are drafting on a bunch of energy humans have done to like add structure to data. And it's not clear we know how to recreate that in a synthetic way. Before we get there, let's just have a simple example. How would you synthetically create language?
How would I synthetically create language?
Let's say we've run out. So we've had 3,000 years of humanity, and we're talking to each other and writing things down, whether it's on papyrus scrolls or stone tablets or on Twitter. We have all of this data. So we've fed all of this data into the big model, and we're saying, oh no, we need more. So now you want to write a program to create more. How would you do that?
So the most intuitive thing is that we would just use one of the existing LLMs.
Right, but that's information theoretically not helping us if you're the soda one, right? So that one doesn't work. But how would you algorithmically create natural language?
In terms of procedural generation, one way to think about it is that we could have essentially interactions between different ways of thinking or different texts. Another way, the kind of economist in me says, just incentivize it, just kind of pay people more.
Right. So I think right now the state of the art is maybe there is an algorithmic approach. I don't know of it. I don't know if anybody knows of it for natural language, right? I think the answer is you just go to the humans. Okay, so but that costs money and that costs energy. And if you look at right now the amount that we pay for this labeled training data, it's really expensive. I mean, like a single task of multi-turn data. By the way, multi-turn data just means that you're interacting with like a question and answer forum, because that's kind of what these chat models look like. So a single task of that today can cost $1,000. And to train these models, you need millions of these. And so one answer to how do we get more data is you go to humans, because that's where it came from, and then you pay them. But we're very quickly getting to the point of economic equilibrium where it's just too expensive to pay them relative to the gain that you get. So that at some point likely is going to tap out. We run out of humans, or we run out of new things for them to say, or it's just too expensive to get. And so it's not clear to me we've got a good answer for how do we continue the growth when it comes to natural languages. But there's many other things and many other modalities you can look at. And this goes to your simulated data, right? So for example, you can absolutely simulate axiomatic systems. Yeah. Right? You could simulate math, arguably. You could simulate code. And by simulate means you could procedurally generate it. And so those areas now are very interesting to explore. But I think many people don't realize that that's not natural language necessarily. Right. That's something else. And maybe there's some crossover. And I think this is an area of rich exploration, and there's more to get out of it. It's not clear to me how much.
Right. But if you were to think of the execution approach, you've been given a task. The task is to generate synthetic data or to explore these kind of open systems.
Yes.
How do you do it? What's the best way to do it?
For me, there's two types of synthetic data. There's simulation and there's search. And so simulation is you're given a set of axioms like the laws of physics, and then you calculate what that system does over a period of time, and then you train the models on the results of that, and then the model becomes effectively a cache for that computation, right? And so anything simulatable you can use that for, and that's clearly very useful. And it seems to be generalizable too, right? So simulation. There's another one which is basically search, where you can use, like AlphaFold did, these kind of recursively self-improvement self-plays where you've got, a fixed set of next steps, you've got a binary win-loss condition, and then it kind of exhaustively searches space by kind of training itself. And so there's a lot of domains where clearly simulated data is very valuable. There's a number of approaches that you can even reason from first principles why they work, right? But to me, the event horizon in all of this is that still doesn't get us to natural language. And so do we care about natural language, yes or no? I think we do care about it. And then is it going to help in the standard use case of LLMs? I don't know the answer. Like, what would you guess are the top two uses of ChatGPT?
Or the top two uses of ChatGPT?
Just guess.
I would say analyzing documents is this from an enterprise context or a kind of individual context?
Just per query across everything.
Yeah, analyzing documents. One.
I think that's the third, by the way.
Okay.
And by analyzing, you mean like summarizing.
Yeah, summarizing.
Retrieval query. Yeah, that's clearly a good one, which is also very natural languagey thing.
Yeah, drafting, brainstorming.
You're way too productive.
Okay.
You're way too constructive. I'm pretty sure that number one is fictional content creation, which is like stories and things like that, and number two is
you get character.
Well, that's kind of companionship. It's actually more content creation. Like, tell me a story about this, create a narrative about this. It's actually and then the second one is basically sex. Yeah, it's like companionship. But listen, these are the two dominant use cases, which they economically stand to reason. Like, computers in the past haven't been able to be creative. Now they can. And they've been, they haven't by themselves been able to create an emotional connection. They clearly can now. But both of these are very clearly the products of natural language, which is, as far as we know how LLMs work, is you basically consume everything ever created, and then you use that to basically linearly interpret an answer. And so what's not clear to me is for the dominant use cases, and the most economic use cases, whether you can throw simulated data at that. Maybe you can. It's just not super clear.
Although it's interesting, a friend of mine has a horniness benchmark.
That's awesome. for LLMs or for humans?
The LLMs. for the LLMs.
Is there a ranking? Can we go like online and see a ranking system for this? That's fantastic.
I'm not sure if this is public yet. I'll definitely put it in the show notes if it is. They noticed that Claude is significantly... Claude is one of the ones that are up there. Of course, the character ones are up there. And then...
Wait. They're horny? Claude is horny?
Yes.
What?
Claude is consistently the horny one.
My experience with Claude is the opposite.
Interesting. Compared to like ChatGPT, compared to, all these other like mainstream models?
I mean, compared to like Llama 3 or...
Interesting. Okay.
I mean, maybe I don't understand what horny is, but like it is the most...
like sexual.
It is the most nerfed model, Claude. Like, I'll give you an example. Last night, here's a day-old Claude example. My day-old Claude example is I wanted an anonymous Twitter handle. For just something silly. So I'm like, give me some names, Claude, for an anonymous Twitter handle. And it said, I'm not comfortable with you doing something. With you doing something that's anonymous, so I won't tell you. And I'm like, okay. I'm like, give me Twitter names, that I can use. And then again, I'm not comfortable you doing an anonymous Twitter handle. Probably it was still in the prompt, the previous one. So I said, it's not anonymous. It was like, okay, here you go. And then like a great list of names. And so my experience is like, it's so awkwardly and clumsily handicapped that it'd be the least likely to elicit, a sexual response. But
yeah, it's interesting because it, it's very path dependent, very prompt dependent.
Yeah, for sure.
What's your non-Twitter handle?
I can't tell you because it's secret.
Let's take a few steps back. The perverse incentive, because I think I want to better outline how that connects to this.
Yeah.
Because if you have this distillation of human data into top models, that implies a action mechanism for why there's that catch-up effect. Because if you've distilled some additional amount of data, information theoretically, right, then you can use the distilled data to train the other model.
Correct. Yeah. Well, just if we're going to be exhaustive, you can get the perverse economic incentive without that, actually, which is these things all rely on data, and gathering the next incremental piece of data gets incrementally hard because it's incrementally rare. And the value of that data is probably lower because it's also rare. And so the leader to the margin, like the marginal value of the next bit of data for the leader is actually lower than that for a challenger. So even without the distillation, historically in AI, we've seen this perverse economy of scale where the leaders takes a lot more investment to make reasonable gains relative to challengers. The distillation just accelerates that now because the challengers now can just draft directly on the leader's investment.
And it's kind of diminishing both in that there's the downslope in availability or kind of upslope in cost for the leader, as well as a kind of downslope depending on how many steps you're behind.
By the way, this is why I think I really think that the economists need to start kind of getting invested and weighing in, because like you, Brian, think in equilibria. And that's the only way to really understand how this stuff progresses. Like, how much does it cost a human being to put in new data if that's the constraint? And then how does that hit an equilibrium? I mean, we're actually hitting like economic equilibria. And the history of AI, in my opinion, and the adoption of AI, even before all this Gen AI stuff, which is like, is it economic enough to be useful to anybody but very large players where 10 to 20% improvement makes sense? The answer has historically been no, which is why the majority of gains have come from the Googles and the Facebooks and the Netflixes and has not come from the startups, just because the economics have not really worked. And so I think to make sense of everything we're talking about, which is, are we doing it a monopoly? Are we running out of data? How much can we get out of new bought data? These very quickly become economic equilibria arguments.
Absolutely. I think that moves us into kind of similar argument that if all of this, if scaling up the model, if there's these kind of perverse incentives, then in a way, having a more advanced model is a public good, right? Both because you can train other models based on it and because there's this kind of research that, there might not be a market incentive to have if there's this catch-up effect. First of all, do you agree with that premise?
I'm not sure I think in terms of goods and not goods in that sense. I definitely think having a model out there has benefits well outside of the company that has created the model. So yes, I think it's again, I don't know about good to me is kind of like this loaded word.
Yeah. And it might be loaded because where we're going, right? Because some people want to create a kind of national AI project, right? To have essentially a massive government subsidy for the next training run. Would that be a good idea?
Well, so here you've got you've got a very biased viewpoint. So let me just kind of air my bias. So
Feel free.
I worked on the ASCII project in the late 90s, which was doing physics simulation on the world's largest computers. It was a DOE effort. And at that time, only governments could buy computers of this size. We ran simulations that were the leading simulations in the entire world, and I think we advanced the industry, the government understanding national security as a result of that. And so given my experience with that level of project, I think it's great for the government to send in and do an Apollo-like investment to push the boundaries of science. I am personally for those types of things, and I have seen how they benefit. And I think AI could be great. We have a national lab with lots of computers, the likes that only the government can really amass. And then you can also focus on objectives and outcomes that aren't purely financially motivated or have to be solvent. You can actually ask much bigger questions as a result of that. And so again, by the way, I understand the other side of this argument, but this is a very personal thing. I personally think that these things are good.
You mentioned that there are outcomes other than finances that we can pursue.
Yeah.
What's the most important one?
The most important one, I don't have a good answer for you on what's the most important one, but I do think that there's very fundamental questions we should be asking that you don't really have the time to ask. Like, to what extent are these things actually good at physics simulation? Like, physics simulation is just not a super large market. It's not super clear that this very inefficient use of computers would be good for it. I do think there's a lot of information theoretic questions to ask around this stuff. And so I'm not sure if there's like Apollo in the sense of I'm not sure this is equivalent to let's solve one problem like Apollo going to the moon. I just think these efforts have a lot of ancillary benefits and they can explore questions, and you have kind of postdocs and maybe PhD students and researchers asking kind of deeper questions that fill out the entire space. I think that's more how I'd look at it.
You mentioned physics simulations. What's the kind of application of having a AI-driven physics simulation?
Well, listen, my belief is AI is terrible for physics simulations, right?
I see.
I don't know. That was just an example that I came up with. But just between you and me, you could simulate enough stuff with enough compute, and then you could train a model on it, and then you're basically just in gradient descent. Anything predictive is probably going to be linear interpolation, and you're going to come up with an okay answer, or you could just run the model. You could actually run the simulation. So I don't know what the fit is.
But what's the use case?
Here's another way to think about this. Let me just put it in a different context. We have tools in computer science, right? And so maybe the first tool was imperative programming, where you have an instruction set that you give to the computer. So here are the instructions for you to follow. This is my program. The benefit of it is incredibly efficient, and then you know all the instructions, so you can kind of bound the program. But the problem is you have to know everything that it needs to do beforehand, right? And so It doesn't fill in anything for you. You have to know everything. And so you miss something or you got it wrong, it won't work. Okay, then we move to declarative programming. So what is declarative programming? Declarative programming is, well, I'm going to give you the formal answer, the formal solution, all the declarations, and then it'll figure out how to get there. Now, but you have to know how to specify the answer perfectly. And if you do that, it'll get there. Now, the thing with declarative systems, think like databases, is you can't really bound the compute to get to that answer set, right? They can take a long time, and these are kind of classically unbounded systems. So a way to think about AI is, okay, well, if you can't write the program because you don't know it, and you can't formally declare the answer because you don't know that, well, maybe we can just show it a whole bunch of data, and then it can come up with everything else. Now, classically, an AI takes even more compute than the last two, and it's less efficient. So you only use this when you have to use this. but it pushes us into a whole new domain of problem. And I actually think, having academia and the government explore the implications of that and all the great applications is just a positive for everybody. But I'm putting it in the context of like the history of computer science. This is a new primitive and a new tool, and we should kind of understand how best to use it. And that doesn't always fit within like business constraints.
Speaking of that kind of diffusion of that new tool, I listened actually just now to a great podcast you had where you discussed AI agents, differences in opinion that you had. So what is your take on AI agents?
I'm a systems person. I did my PhD in computer science systems. Like, I'm a systems guy. I was a distributed systems programmer. I've done physics simulation. I did computational physics. I'm not an AI person, a native AI person. In that sense, I always think there's this kind of strange perspective a lot of AI people come from where, and listen, I mean, I work with many of them very actively, where their goal is AGI. Let's get to the agents in a second. Their goal is AGI. And to me, AGI is just kind of arbitrary, weird, non-goal. Like, I like aspects of computer science you can use to solve any number of problems. And in my perspective, if we build a system that solves AGI, great, that was one app. We'll go solve another one. And you know what other one we're going to solve? I don't know. We'll solve grand unified theory. And then physics goes away as a discipline. So now we've gotten rid of AI and we've gotten rid of physics. We'll go solve the next one. And so my personal interests and passion are computer science system primitives that are kind of a meta discipline that solves all of these ones. And I do feel that a lot of the AI has this AGI on the brain, that somehow that if we solve that, then we're done. And I just don't even see that, right? Let's imagine we solve it and it's very expensive. So you've got a bunch of out-of-work robots, right? And so that's a whole line of AI that I'm hoping that we slowly tease away from, where people will view this as like just another tool in the toolkit, and there's many problems to solve, and AGI isn't like the inflection point in the pinnacle. It's interesting, but it's not that. I think because AGI has been such a guiding light, we so often take this computer science primitive and try to turn it into like some autonomous thing. And it's not obvious to me that these are the tools to do this, right? So for example, if you take classic LLMs, we know that they have let's say three very clear shortcomings. Correctness, very clear shortcoming, which is great. I'm from distributed systems. They're often not correct. 2, they have no memory, and if you extend them with memory, that memory is not part of the reasoning fabric, right? It's kind of a separate thing that you pull out.
Right, it ends up being a resource rather than a kind of, human-like memory.
Yeah, it's not integral. And then as a consequence of those two, you have this third thing is where these models can't provide any guarantees on their internal state if you build a system or a control loop out of it that I've seen yet, right? And so you can solve a number of problems by putting them in a control loop and making them part of a solution, but it's not clear to me like the right goal is like these things are autonomous and we're going towards AGI, and then you just press a button, they go off and do something. I mean, they seem like terrible tools for that.
Yeah,
to me, right? And I just feel like if you come from the school of AI, so often like you showed up at the party with the goal to solve AGI, and that's a laudable goal, but it's certainly not the only goal. And to me, it's not necessarily even a panacea, and there's many other things to solve. And so I just tend to focus on the other things.
Yeah, what's really interesting with the AI agents, the kind of you press a button and it goes off and does the thing, is that from a kind of probability perspective, that seems like an odd goal. Because if you think of there being an existing process, there's some number of failure points, right? The more decision points it has to continue for, the probability of failure grows exponentially.
Yes, 100%.
Right?
Yeah.
So if you have all of these dependent processes, then to me, a kind of integrated version where, there's still a human in the loop, they're used to the processes, they've done, or they've accumulated all of these institutional approaches to solving them, works decently enough on the day-to-day, essentially trying to take that entire process and replace it rather than have it kind of naturally accumulate in the same way that you might have other technologies that you've seen be adopted by firms before. That seems like a very odd goal, and I'm wondering, like, what is the kind of psychological motivation behind that?
That's a good question. Listen, it does capture the imagination. The early results are very interesting. There's some subset of this problem. There's some subset of the solution space that they're currently doing. I do feel a lot of it is where we came from, which is this notion that, AI means AGI means, in some sense autonomy and generality. And so we should be able to give high-level directives. Those high-level directives are going to be able to kick off these agents that do things.
So fiction.
I think it's actually very fair to think a lot of this came from our ideas of what AI is. A lot of that was heavily influenced by fiction and science fiction. I think that's totally fair. I'm just going to go a little bit on a limb and say something that maybe is a little bit out there just to kind of wind this up. Do you know why Claude is named Claude?
No.
Claude is named Claude because of Claude Shannon.
Ah, okay.
And the first person that actually, in my opinion, you could argue this, whether it's Markov or not, but the first person that's created an LLM is actually Claude Shannon. If you look, there's actually this kind of beautiful paper he wrote, which talks about kind of next token prediction. And of course, Claude Shannon was an information theorist. And I think we get a lot of real bounds in how these systems work based on information theory. But I actually think it helps us think through the utility of these different type of models in this agentic sense. If you have a model that spits out an answer on a prompt and you feed that back in, you're not increasing information at all. In fact, like you end up, if you're training on the data that creates, you end up with model collapse. And so in order for these things to process information in continuous fashion and do something new, you clearly need new information that goes in. If you have 5 different models, that's also the same because you still have a closed system, right? So then, okay, what if you do an agentic loop where it's getting information from the environment? If you look at that marginal information it's getting from the environment and you compare that to all the data it's trained on, it is so diminishingly and vanishingly small, it's hard to believe you'll ever be able to change behavior correctly. So right now, to date, I believe the best approach to having these models be very successful is you have like the one AGI that we know of, which is you and me, and then we provide kind of the guidance and the correctness that they will then use for whatever task that they're doing. And it seems to me that this is kind of how a lot of this is playing out.
Right. That actually sparks one more question on this front. I think the idea you mentioned here is the kind of entropy bounds,
yes,
right?
Correct.
The kind of total information within a system.
Yeah.
But just in terms of user endpoint, I think something very interesting here is that when it comes to using a limited API endpoint, ChatGPT, for example, a big problem people will have is that it'll have failure modes that are random that need the user to correct it. Yeah. So to me, this trade-off reminds me somewhat of the kind of error correcting codes, right? That you have some amount of compute and some of the existing kind of quote unquote agent systems for software work like this. You have some kind of loop where you're prompting it, you're getting some output, and then you have another system that either, tries to compile the code, right, in the case of some of these software agents. And if it doesn't compile or if it doesn't pass the system tests, then, it resets, it uses more compute. And then there's this kind of very hazy bound around what actual amount of compute and what actual amount of resource it takes to get a question correct. So do you think that there's a kind of scaling law for error correction?
No. I mean, listen, so I've worked a ton on error correcting codes. I'm a networking guy, right? In that case, you actually have a formal notion of correctness on either end, which is like the bits that go in are the bits that go out. And then you use how lossy the channel is to put a bound on like how many bits you need for error correction, right? This is like a very constrained system. But when we're talking about LLMs, often I don't even think the user knows what they want. I think part of it is this kind of very iterative experience, experience where I put in a prompt and it gives a response, and then maybe it's what I was looking for, maybe it wasn't what I was looking for, and then I continue to iterate on it. And so I just think a lot of the use cases, like the ones we've talked about, like companionship or sex, there is no formal notion of correctness. And if there is a formal notion of correctness, I suspect you probably don't want to use an LLM. I just feel like the LLMs are in a different space because to you, the hallucination is an asset because you're doing fiction. And to me, it's a bug because I actually care who discovered the Roman village of Urthi, right? I mean, they're just very different uses.
So let's move into the kind of politics segment. What is little tech?
Little tech, variously described, is private companies So they are technology companies that are private, that are not, in the classification of big tech, which you tend to think of as public, massive resources, probably part of an oligopoly, have lots of lobbying resources, etc.
Right. What clearly defines them as a different interest? I know you already got started on that part.
Well, they just aren't represented in the same way. I mean, normally the little tech's competition is big tech, and so you almost have like an ecosystem where you can separate. Like if you take some random startup, in almost every case the competition is not another startup.
Yeah, this has been something that I've been trying to get through to policymakers for a while, that in many cases for startups, big tech is sharks in the water. When they advocate for a policy, that there's as good of an odds that a sort of anti-competitive policy, it's doing something against the smaller tech companies as it is to be actually benefiting them as a kind of shared defense.
Yeah, that's right. So more regulation and more policy helps bigger companies that can do it. GDPR was probably the best thing that could have ever happened to Meta. And so if you don't know what GDPR is, GDPR was basically these rules, these laws placed in Europe that required a whole bunch of ability to delete private data, and you had to let a user know, about the cookies, and then they decide whether to do the cookies, etc. I mean, there's a bunch of policy wrapped around the online use. And it's under the auspices of consumer protection. Right, which is now
as these things tend to be.
As these things tend to be, the reality is it's very hard for startups to stay compliant to these rules. It's incredibly hard, right? The rules are very complex. They are the output of a political process, not sort of a technical or a market process. So they tend to be baroque in that sense, and then they require resources to do, and often re-architecture, et cetera. So of course a big company can do that and internalize that, and so these types of policies often aid big tech, very much to your point, at the expense of startups.
So there's this classical political economy problem. If you take all of the startups and you combine them together, right, in many cases they could be worth even more than a Meta or all these big tech companies combined. But they're vastly underrepresented in terms of lobbying spend, and there's all sorts of institutional problems. The interests are kind of diffuse instead of concentrated. That's how an economist would put it. And there really isn't anyone standing up for any of these smaller companies, even though if you add them together, right, you would assume that such an interest exists. Do you think that's on its way to changing?
So I think that the path that we got here is actually very important, which is I think for the most part, the U.S. government and let's say the California government have been pretty pro-business, and we've done a number of our missteps, of course. But startups get created, and startups, have changed the industry. Tech has been generally viewed as positively, and I think it's
pro-business and just pro kind of tech or pro software, right?
Yeah, pro-innovation, pro-software, pro-tech. I mean, it's just generally been so, with some exceptions, right? And I would say up to 2014, 2015 even. It was relatively recent. I think it was the social networking wave where the policymakers feel like they kind of lost control, and a lot of them are worried about things like, election meddling or deep fakes or whatever. And they kind of felt that they didn't have the level of control they needed. And so they built up a lot of machinery against that. And that machinery has found new things to focus on, like crypto and AI. And the result is almost, in my experience, is an almost entirely, an entire shift in our tenor towards how we view tech. And unfortunately, the large companies stand to gain from this because this just means lots of regulation, and startups are in the crosshairs and stand to lose. And the problem is so acute right now that you're seeing organization around this specific issue. So yes, this is changing now. Yes, you hear people talking about little tech. Yes, when you hear Andreessen Horowitz, of course, has been kind of banging this drum for a while. And so I do think that this is an artifact of a shift in posture from the United States. I think it's very real. I think little tech stands to lose, and I think it's actually necessary.
Famously, in pharma, if you are a startup, your goal is almost always simply just to get acquired. Because in order to have the funding, in order to have both legal and kind of technical work to actually clear late-stage pharmaceutical trials past the FDA, you need the support of a big company. And it just makes sense to kind of hand off the IP, hand off the resources, and do those trials as part of a larger company. Little pharma just has completely lost regulatorily. How do we avoid that? How do we make sure that the story actually is different?
It's probably worth talking about even M&A, right? I mean,
yeah.
So in order for the little tech, so I've started 2 companies of my own before being an investor. I sold both of those companies. One was a great exit. The other one was a modest exit. In order for entrepreneurs to be incented to start companies, and in order for them to come back into the ecosystem, if they don't build a full public company, you need M&A. Like it's a strict requirement for any of this work. And we're in the most hostile environment I've seen in my entire life towards M&A. And that alone is massively, massively chilling the effectiveness to which we can solve new problems and we can innovate here in Silicon Valley. And so this is a great example of a dramatic change in posture that has negatively impacted tech broadly. And so even in your case, even in the case that you brought up of pharma, if your last resort is just to do basic R&D and then get acquired, even that is being cut off. So I think that the situation is very dire. I think this is a great question that you asked outside of that, which is how do you prevent, software from becoming, biotech or something like that, where that's the thing. And I honestly think it's just very sensible policy, of which we have a 30-year discourse. This is the thing that, for me, that's the most frustrating, is software policy has been around for a very, very long time. In 2003, I taught a course at Stanford. I helped create and teach a course at Stanford with William Perry, who was the Secretary of Defense under the Clinton administration, on cybersecurity policy. And we weighed the issues of innovation versus like critical risk to the country, et cetera. This is 20 years ago, right? And so we have this very robust discussion around software and policy and how you balance the two so you can have innovation, yet you can have safety. And that has been working very well. And if I gave one recommendation to anybody listening to this, especially if you're a policymaker, is don't throw away that rule book, because it was working. Like, that's it. Like we've listen, this is an ongoing discourse. Become part of that discourse. Let's use it in the context of what we've learned and don't throw that away. If we throw that away and we arbitrarily create policies from whole cloth, we may not strike the right balance. And then all of a sudden, from the perspective of California, I know you're asking more broadly, but for being a Silicon Valley guy, I think from the perspective of California, you're throwing away the greatest growth driver in the world, which is a gem to the state and should, to me, as a national, it's a world treasure for political purposes.
Yeah, it seems like whenever there's an argument for a policy shift, there has to be some kind of excuse of why the precedent is either incorrect or, it doesn't apply to the current situation. How do we defend that precedent? What
you just said is just so important. So I just want to make sure all of us just take a moment to like understand what you just said, because it's so important, which is there's a long discourse in software and in tech on policy, right? So why would you ever change the policy? It's because you have a paradigmatic shift. And I mean paradigm
Yes.
in the sense of the Kuhnian sense, right? Like there is a marginal risk that is different. So we actually had this in the time of the internet. So when the internet came up, there was two examples that were very clear. There was a new emergent types of attacks that were demonstrated. So the internet came up, someone created a worm, Robert Morris, now a professor at MIT. It was called the Morris worm. It demonstrated that you could actually damage systems that were putting critical infrastructure on. So we had an emergent threat. And the second one, it's a little more abstract, but there was this notion of asymmetry, which means from a national security standpoint, if you use more technology, you are more vulnerable because you relied on it, right? So if whatever you're dealing with, a conflict in a non-technical space, then they could attack you more than you could attack them. That was kind of the idea. So you had two clearly identified marginal differences, a known risk that was shown, this notion of asymmetry, and we developed policies around this. So it was a very metered, very well thought out approach to policy. That exercise of what the marginal risk is and the paradigm shift is totally missing today. In fact, many of the policymakers I talk to about this just look at me blankly when I bring this up. And so, again, I didn't mean to derail this, but you're absolutely right. Whatever we do has to be in the context of marginal changes. Otherwise, we lose all of the learnings of the past 30 years.
Although I would say that on a federal level, there's more optimism towards that front with things like the bipartisan Senate report led by Chuck Schumer, where I think it does take more of a marginal approach.
100%. And that's actually, I would say, relatively recent. I actually think that the U.S. Federal policymakers are doing a good job of converging on a reasonable approach here. When I first went to I was invited to talk to these panels on this AI risk. When I first went, it was all about we need a new FAA and you don't let airplanes fall out of the sky before you create the FAA. And it's actually converged on focusing on marginal risk, which is great in a bipartisan way. And Chuck Schumer's done a fantastic job of that. California, on the other hand, is a disaster.
Yeah, we saw. People who follow me will know too much probably about SB 1047. I'm sure your followers are
tired
the
of
same.
me talking about it too.
Yeah,
I know.
There is one SB 1047 related point I want to ask though. Yeah. There have been rumors, tweets. Are you interested in primarying Wiener, or just getting rid of him?
So of the two people that are on this podcast right now, you and me, you know a lot about politics. I know nothing. I don't even know what that really means. The only reason that I am part of this discussion, being a political discussion, is I have been part of tech policy, and I know this is very bad. And so that is one of the only things that could ever drag me off of my keyboard and to talk about this issue, is the fact that I know how bad it is. And so I actually don't have any ambitions to be broad politically active. I don't have any ambitions outside of SB 1047 and narrowly focused on these types of issues. I will say I've been incredibly disappointed in him as a lay person and how he's handled himself, how dramatically he's misrepresented what I have said and what others have said. I will never support the guy for sure. But other than that, I just don't have broad ambitions to be involved in politics.
You want to call it there?
Yeah, I think it's great.
Awesome. Thanks for listening to my episode with Martin Casado. If you liked it, the best way to help the show is to let a friend know, either in person or online. You can also help us out by leaving a 5-star review wherever you're listening, leaving a comment, suggesting future guests, and, if you wish, subscribing to the paid Substack, where you'll also get a bunch of bonus articles. And, as always, if you want to catch another great episode every week, subscribe for free wherever you're listening right now. See you then.